the Spare Air, Heed, Spare Air Extreme, Spare Air Industrial, and Spare Air Escape are all versions of a complete emergency breathing system in an all-in-one unit produced by Submersible Systems. Spare Air is the invention of Larry Williamson, an avid scuba diver who almost died in a dive accident where his air supply failed while at depth. Seeing the need for a simple and unobtrusive breathing system with a separate redundant air supply, Larry created the Spare Air. The first Spare Air was distributed in 1979, and since then over 250,000 models have been sold worldwide. After more than 3 decades, the Spare Air evolved into the current next-generation design. The Spare Air provides an independent air supply for scuba divers at depths up to 130 feet. After the Spare Air was made popular by scuba divers, the Helicopter Emergency Egress Device, or HEED, was developed at the request of the U.S. Navy to increase survivability of military and commercial personnel during short-term out-of-air emergencies. The Spare Air Extreme is the choice of extreme sportsmen like tow-in surfers and kayakers, offering hands-free operation. The Spare Air Industrial is ideal for escaping short-term toxic air emergencies. 50 to 80% of all fire deaths are attributed to smoke inhalation. The Spare Air Escape, packaged with a mask, provides a few extra moments of life-saving air. The Spare Air is composed of a balanced, single-stage, on-demand regulator, high-pressure cylinder, check valve, and pressure indicator. Upon inhalation, the diaphragm depresses the lever, pressing the poppet assembly down and away from the poppet seat, allowing air to flow from the cylinder into the regulator chamber and out of the mouthpiece. Upon exhalation, the diaphragm is forced upward. The poppet assembly and seat are forced closed by a spring. Exhaled air exits the regulator chamber through the exhaust ports at the bottom of the regulator. This video is intended as a guide to accompany Spare Air and HEED repair training and certification. All repairs for units under warranty must be performed by Submersible Systems, or the warranty will be void. Serial numbers are located on the regulator to the right of the mouthpiece. Spare Air models made from 1979 to 1999 are no longer serviceable. Old models are eligible for a trade-in credit when upgrading to a new model. Contact Submersible Systems for details. We recommend the Spare Air be overhauled on a yearly basis and the HEED every 5 years. However, do not wait for an annual checkup if leaking or damaged. During annual service, all cylinders require a visual inspection. Based on DOT standards, we recommend condemning any cylinders with pitting greater than 0.03 inches. Cylinders require a hydrostatic test every 5 years. O-ring seals are used throughout the regulator. A clean working environment is required to obtain effective O-ring seals. Never install new parts into a dirty or corroded regulator. The Spare Air Nitrox model is Nitrox ready up to 40% EAN and requires the Nitrox Overhaul Kit 094 NTRX. Be sure to use a halocarbon-based lubricant. Before disassembling, evaluate the regulator to determine its condition. Old or highly corroded models may require further evaluation and overhaul service from Submersible Systems. If the regulator is leaking, determine the source by submerging in water and rotating to release trapped air. Check all O-ring seals for leaks, checking for a stream of constant bubbles. Dirty or damaged O-rings are the most common cause of leaks. The following parts are included with every 094X overhaul kit: O-rings for pressure indicator, poppet housing and both ends of check valve, tank O-ring, check valve stem with O-ring, poppet assembly, poppet seat with installed O-ring, nylon washer, burst disc, filter, and VIP sticker for cylinder. The 710NX toolkit contains specialized tools required to properly perform an overhaul. The kit includes a 1/16 inch hex key, a 3/16 inch hex key, a large flathead screwdriver with a 1/8 inch thick blade, a lever height gauge plus inner ring tool, a poppet housing tool, a flow no flow gauge, and a rubber gripper. A dental pick or O-ring tool may also be utilized. Parts may be seized or frozen due to corrosion from improper preventative maintenance. Do not force the removal of parts. If necessary, soak in a 1:1 vinegar and water solution before disassembly. Purge until empty. Fold upside down and unscrew the cylinder counterclockwise from the regulator. Perform a visual inspection on the cylinder and hydrostatic test every 5 years. Insert an inspection light into the cylinder and inspect for any salt corrosion or pitting on the inside wall. If there is any sign of dirt or salt residue, the cylinder should be thoroughly cleaned and dried before reassembly. Remove the tank O-ring, tank washer, and both exhaust discs. Discard the tank O-ring. Place palm over purge button. Push down on edges and turn counterclockwise, removing the outer ring. Use a rubber gripper if additional traction is needed. Using the inner ring tool, place the 2 pins of the tool in 2 of the slots of the inner ring and turn counterclockwise. Remove both the inner ring and the purge button. Gently remove the diaphragm. Using the large flathead screwdriver, unscrew the burst disc plug counterclockwise. Turn the main body upside down. The burst disc and nylon washer should drop out. If the nylon washer is stuck, carefully remove it with a dental pick or O-ring tool without scratching the surface of the main body under the nylon washer. Discard the burst disc and nylon washer. Remove the poppet housing with the poppet housing tool by unscrewing counterclockwise. Lift out the poppet assembly. Be sure the O-ring on the bottom of the poppet assembly is also removed. Turn upside down to remove the filter. If the filter does not drop out, use an air gun to blow it out. Discard the filter. Strip the spring, washer, and O-ring from the poppet assembly. A new poppet assembly is included in the overhaul kit. Insert the plastic stem into the poppet housing and wiggle out the poppet seat. Do not use a metal tool that may scratch the inside of the poppet housing. Discard the poppet assembly and seat. Using a large flathead screwdriver, remove the pressure indicator by unscrewing counterclockwise. If the unit is equipped with a dial gauge, carefully use pliers to remove without damaging the surface. Using a 3/16" hex key, remove the check valve assembly by turning counterclockwise. Remove and discard the check valve stem with O-ring, but keep the spring. Remove and discard the O-rings from the pressure indicator, poppet housing, and check valve. Wipe clean the pressure indicator to remove all grease and debris. Degrease all other reusable parts, including the main body, in a hot soapy water solution. Rinse with fresh water. To remove corrosion, soak parts in a 1:1 vinegar and water solution and place in an ultrasonic cleaner. After soaking, rinse parts with fresh water. Blow regulator portholes clean and completely dry with low pressure air. Internal portholes must be free of all foreign particles before assembly. Any debris may cause damage and prevent O-rings from sealing. Blow all parts until clean and dry. Inspect all surfaces of the main body that contact with O-rings for nicks, scratches, and contamination. Inspect the mouthpiece for cuts and deterioration. On the cylinder, perform an annual inspection and hydrostatic test if necessary. Inspect metal parts for corrosion, stripped threads, and seized moving parts. Inspect the diaphragm for tears in the membrane. Inspect each exhaust disc for tears and holes in the surface. We recommend using a high-quality, non-toxic food-grade silicone spray on all metal threads and O-rings during assembly. Do not lubricate the diaphragm. If lubricated, the edge of the diaphragm could become misaligned. Install a new O-ring on the internal and external threads of the check valve. Place the check valve stem on the spring and install into the open round end of the check valve. Lubricate threads and install the check valve assembly into the left-hand port. Tighten to 60 plus or minus 5 inch-pounds, or hand tight. Install a new O-ring on the pressure indicator. Lubricate the threads and screw into the right-hand port on the main body. Torque to 60 plus or minus 5 inch-pounds with a large flathead screwdriver or torque wrench. Drop the filter into the bottom of the poppet port with the lip of the filter facing up. The filter must lay flat at the bottom of the poppet port. Holding the pin of the poppet assembly, lightly lubricate the O-ring and insert straight into the main body through the center of the filter. Blow out and lubricate the inner cavity of the poppet housing. Push the new poppet seat into place with the poppet housing tool. Install a new O-ring on the poppet housing and lubricate the threads. Screw the poppet housing down into the main body using the poppet housing tool. The poppet housing should rotate about 5 1/2 turns before stopping. Back off the poppet housing until the end of the long lever is directly centered over the burst disc plug porthole in the center of the main body. Install a new nylon washer into the center burst disc plug porthole. Install a new burst disc on top of the nylon washer. Both should lay flat at the bottom of the porthole. Lubricate and install the burst disc plug. Tighten to 60 plus or minus 5 inch-pounds or hand tight. Place the largest exhaust disc over the threads of the main body. Follow with the smaller exhaust disc. Then the metal tank washer. And last, the tank O-ring. Lightly lubricate the threads on the main body and screw on the cylinder. Torque to 60 plus or minus 5 inch-pounds or hand tight. Before making adjustments, fill to 1000 psi and hold the lever on the poppet housing all the way down until completely empty. Do not tap the lever. Repeat the process. This will clear out any residual debris. Refill to 3000 psi. The lever height gauge has 2 steps for fine adjustments. Use the lever height gauge to measure the lever height 1/4 inch below the top edge of the main body. Place the gauge centered across the main body over the lever. The first step should let no air escape. Move the gauge, aligning the poppet lever under the second step. Air should flow slowly. Make necessary adjustments using the 1/16 inch hex key to raise and lower the lever. Turn the set screw clockwise to raise and counterclockwise to lower the lever height. Fully pressurized, submerge underwater to perform a leak test. Hold underwater for at least 30 seconds, inspecting all O-rings and threaded ports. A leak is a steady, continuous stream of bubbles. Place the diaphragm into the inner top ledge of the main body. Place the purge button over the diaphragm. Thread the inner ring with slots up, clockwise over the purge button using the inner ring tool. Turn until contact is made with the purge button. Then turn 1/8 inch more. Check again for the correct adjustment of the lever height using the flow/no-flow gauge. Insert the short stem into the center hole of the purge button. No air should flow. Insert the long end into the center hole, and air should flow. If necessary, remove the inner ring, purge button, and diaphragm. Adjust the poppet lever using the lever height gauge and hex key as before. Place the outer ring over the top of the main body and turn clockwise with the palm of your hand until there is no gap between the main body and the outer ring. If there is a gap, remove the outer ring, tighten the inner ring 1/8 inch turn, and reinstall. Test inhalation for ease of breathing. Refill to 3000 psi and replace the check valve cap. Consult the service manual troubleshooting guide for causes of leaks and breathing problems and their remedies. By following the standards set in this video, you are helping to provide spare air and heat users the best opportunity for self-rescue in an out-of-air emergency. Consult your service manual for part names, numbers, and a complete step-by-step guide to servicing all submersible systems breathing devices.